In this video, we're going to be looking at the real zeros of a polynomial function. And we'll be looking at a couple of theorems, 2 or 3 theorems. Let's look at the first two first here. So the first one here is the Remainder Theorem. It states if p of x is a polynomial and p of x is divided by x minus c, then the remainder is p of c. Well, let's look at one example here. Let's say we have p of x equal to x squared minus 4. And then we can rewrite this also in factored form. So we'll do that so we can see this more clearly. X squared minus 4 factors into x minus 2 and x plus 2. So you can see there that the factors in are x minus 2 and x plus 2. So it's clear that x minus 2 divides the polynomial. Remainder is 0. X plus 2 also divides it. So notice again, if I evaluate this polynomial, the factor should be x minus 2, and the other factor has a plus, so I have to rewrite that as x plus or x minus a minus 2. So notice if I evaluate this polynomial at 2, I get 0. If I evaluate it at negative 2, I also get 0. So that's what this is saying. If you divide by x minus c, then the remainder is p of c. So in other words, I don't have to use a long division or a synthetic division to get the remainder. All I have to do is evaluate it at c. In this case, at 2 and negative 2. The second theorem is kind of related. Factor theorem, if p of x is a polynomial, then x minus c is a factor of p of x, if and only if p of c is equal to 0. So here, I can say then that x minus 2 is a factor. I can also say x minus a minus 2 is a factor because of this same situation here. So let's look at the first one. So you find the remainder if f of x equal to x to the 4th minus 3x cubed plus 2x to the minus 4 is divided by the first one, a, is x minus 5. So for a couple of ways I could do this based on what we just went through. I can just evaluate this polynomial. See, this is in the form x minus c here. So just evaluate this at 5. C is 5. 5 to the 4th there. 5 to the 3rd there. Multiply. 5 there. If you go through that calculation, this gives you 256. That's the answer to part A. Now, if this power is large, say this is to the 7th power here, or 8th, it's more involved, so sometimes it makes it easier if you use synthetic division. So for synthetic division, you need this in descending powers, and then you take the coefficients in order there. So 1 minus 3. There's a missing x squared here, so put a 0. And then you got a x to the first 2, and you get a minus 4. So instead of plugging it in, you can do it this way. So what we're doing basically is just dividing the polynomial by x minus 5 using synthetic division, and we put the c right here. That would be a 5. Bring this down, that's 1. 5 times 1 is 5. And add this, we get 2. 5 times 2, that's a 10. Add, we get a 10. 5 times 10 is 50. Add, we get 52. And then 5 times 52 is 260. Add, we get 256. And this is the remainder. Get the same thing. One of those theorems, we get this. Now, for part B, if I do it this way, evaluating, okay, in this case, it's x plus 4. So you're going to write this in the form x minus a minus 4, so it fits the theorem. So then you just evaluate this at minus 4. And if you do that, you get 436. And that's the answer. In other words, if we divided this polynomial using synthetic division or long division, this would come out to 436 here. Here you'd have a negative 4 instead of the 5. So those are the answers for that one. Now number 2 is kind of related. It says use the remainder theorem, combination of the factor and the remainder theorem. Use the remainder theorem to determine whether the function f of x here has the factor x minus 3. So for a, you would do the same sort of thing and say evaluate the polynomial. So evaluate the polynomial at c. This would be x minus 3, so that'd be x minus c. Plug it in and you get 0. So from the factor theorem, because we got 0, this tells me yes, it is a factor. Now you can do the same thing like I did in part 1. You can use synthetic division instead and then check the remainder. If the remainder is 0, it is a factor. If it's anything else, then it's not a factor. Now for this one here, part B, we find f of negative 2, and this should give us 50. So in order to be a factor, the remainder has to be 0. So we got 50. So for this one, no, it is not a factor. And of course you can do it using synthetic division like I did in part 1, or problem 1. For problem 3, say solve the equation x to the 4th minus 2x cubed minus 8x squared plus 10x plus 15 equal to 0. Now we can get the answer if we can factor this out. So there's another theorem we can use when you have these types of problems. It's easier to get the solution if we can find at least one factor or more, and we can do that by finding zeros or using the Rational Zeros Theorem. The Rational Zeros Theorem tells me that if P over Q is a rational zero, that is one that is a fraction, like 3/5 or 1/2 or whatever, then it must turn out that, and this is in lowest terms, this has to be in lowest terms, then P will be a factor of whatever this constant is, and Q will be a factor of the coefficient of the lead term. This is a 1. The only factors of 1 are plus or minus 1, and the factors of 15 are plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So the Rational Zeros Theorem tells me that if a certain polynomial has a rational zero of the form P over Q, then it has to be a factor of the constant term divided by a factor of the lead term. So basically it's one of these divided by plus or minus 1. Well, if you do that, you get the same thing back. So this tells me that the only rational zeros of this polynomial are going to be either plus or minus 1, plus or minus 3, plus or minus 5, or plus or minus 15. P over Q is a rational zero. P has to be a factor of 15. The denominator has to be a factor of the lead term. So what you do here then is set it up this way. You got 4, 3, you got 4, 3, 2, 1, and then the constant. Those are the exponents. So this has to be in descending order. So we're going to put a 1, minus 2, minus 8, plus 10, and 15. If there's any missing terms there, in other words, if I didn't have the x cubed, then this would be a 0 here. And then you just pick what are the possible rational zeros. Well, plus or minus 1, plus or minus 3, and so on. So you would try here and use synthetic division. If it doesn't work, then go to the next one. 1 or minus 1 don't work. 3 and minus 3, well, we're going to try 3. Going to try 3 and go 3 times 1 is 3. Then we get a 1. 3 times 1 is 3. And add here, we get a minus 5. 3 times minus 5 is a minus 15. Add, we get minus 5. 3 times minus 5 is a minus 15. Now if you get a 0, that tells me that you have a solution because the x minus 3 would be a factor. So I get it again here. Now it's possible you could have a repeated solution, so you might want to try the 3 again, but it doesn't work for a second time. So we'll stop there. And I skipped the 1 and the -1, but it turns out that the -1 did work. So let me do this. Try -1. 1 did not work. And then we just start again here. Bring this down. -1 times this is a -1. This will be 0. -1 times 0 is 0. And then bring this down, add it up. -1 times a -5 is a +5. We get 0. So that tells me that -1 is a 0 of that polynomial, or another way to say it, x minus that, or x plus 1 is a factor. So the solution, based on what we've done so far, 3 is a solution. Because 3 is a 0, which means x minus 3 is a factor. -1 is a 0. Remainder 0 here, which means x minus that, or x plus 1 is a factor. -1. And what do I have left here? This started off x to the 4th. One division gave me x to the 3rd. Another one gave me x squared. So this is actually x squared here, plus or -5. X plus or -5. This then is what I have left. It's a quadratic expression. So what could be the solution? This would be one factor. So set that equal to 0 to solve it. Once you get it down to a quadratic, then you can use factoring, or you can use a quadratic formula. Here, because I'm missing the x term, I can just set this equal to 0 when I get x squared equal to 5. Take the square root, plus or minus, so it's be plus or minus the square root of 5. So the complete solution to this one then is 3, -1, and plus or minus square root of 5. Thanks for watching. We'll see you next time.